Okay, last chance. Anybody think they have the answers? Anybody want to try and get 15 gummy bears? Nobody? Everybody's just letting it go? 15 free gummy bears? Nobody? Yeah, okay. Oh, well, all right. So, you think you have it? Tell me what your answers are. What does A, B, and C equal? 1, 2, and -2. You're very close. It's not quite right, but you're very close. It is a variation of those numbers. You're absolutely correct. Kind of. We'll show you. All right. So, this first one, obviously, the smart thing to do is divide that by 2. I think. Because then you get y equals 5 over 2x plus 1. And then, what would be the next smart thing to do? I would move that 3 over there and get y equals 1/2 x plus 4 plus 3. Now, if y, oh, where's my stupid highlighter? If y equals that and y equals that, then doesn't 1/2 x plus 2 plus 3, which is 1/2 x plus 5, equal 5 over 2 x plus 1? Then, of course, you can find x. How would you find x? Well, you could do algebra, or you could multiply the whole thing by 2 to get rid of the numbers, which gets you x plus 10 equals 5x plus 2, 4x equals 8, x equals 2. Then you go back up here and you plug in for y, and you get, I think y was 5. Y was 3, wasn't it? 5 times 2 is 10 plus 2, 6. 2, 6. Yeah? Yeah. Now, could you also have done that with graphing fairly easily? If you wanted to, you could graph that super easily because it works out to a perfect 2 and 6. No decimals, yeah? So you could have graphed it if you'd wanted to. Now, what about this one? This one is super barfy. Did anybody complete it? I know Madeline did, and I know Parm did. What was your first step, Parm? Oh, you didn't? Somebody over there said they had the second one done. No? Nobody tried the second one except Madeline? No one? Interesting. Okay. Well, Madeline, what did you do first? You multiplied this guy. I would have multiplied it by -5, but that's cool. She multiplied this guy by 5, so she ended up with 5/9 x plus 5/7 y equals 15. Then, of course, once she had that, it was really easy to eliminate y, wasn't it? Because all she did was subtract it. Yeah? 2/3 is really 6/9. So 6/9 minus 5/9 is 1/9 x. These disappeared, and 16 minus 15 equaled 1. And then x equaled 9. Then she just went back and subbed in, and got y to be, what was it, 14? 14. She also could have multiplied everything by multiplied everything by 63, and then she would have had no fractions. But then the numbers would have been big. Now, I would highly suggest that even the back corner, which doesn't seem to care about this, should probably pay attention to this one. Because this one is extraordinarily difficult seeming. But it really isn't when you stop and think about it. Why is this difficult? Because there are 3 variables, yes? So I'm just going to separate these out like this. Now, why was it difficult when there were 2 variables? Because 2 unknowns, you can't solve it, right? What was our move to fix it? We had to eliminate variables, right? Okay, so if there's 3 variables, shouldn't we just try eliminating variables? Well, let's see what happens. What do you notice right, get my highlighter, there and there? I could eliminate the b's, couldn't I? Okay, so if I do that, I could eliminate the b's, right? Now, what do you notice here? C is by itself, isn't it? So, isn't C the same as 4 minus 2a minus b? Isn't it? And then right here, aren't we eliminating the b's? Everybody with me? So let's do some stuff and see what happens. Let's eliminate these b's. So is this add or subtract? Add. So what is a plus negative 3a? Negative 2a. And what is 3 plus negative 2c? 3 minus 2 is 1. So plus c equals 7 plus negative 10, negative 3. Yes? Are we happy? All right, so we now know that c equals negative 3, right? Negative 3 plus, 2a plus 3, right? Are we happy with this? Everybody follows my thinking there, yes? Okay. Now, up here, don't we also know, or now that we have this as c, where can we put that c? Anywhere we see a c, right? Well, what's the easiest c to work with? Right there, yeah? So I can get 4a plus b plus 2a plus 3 equals 4, right? So 6a plus b equals, bring that 3 over 1. Is everybody cool to there? 4a plus 2a is 6a. Oh, sorry, 2a. I already added it in my head before I wrote it. Sorry. 4a plus b equals 1, right? Everybody's cool there? So I know what c is, right? I know, now don't I know what b is? 1 minus 4a, right? So I've eliminated b, I've eliminated c, and I've only got a's left, yeah? So what can I do now? What do I see right there? A single a, right? A minus 2, what's b? 1 minus 4a plus 3, what's c? 2a plus 3 equals what? Seven. A minus 2 plus 8a plus 6a plus 9 equals 7, yes? A plus 8a is 9a, plus 6a is 15a. Negative 2 plus 9 is what? 7, right? Wait, sorry. 15a equals 0. Can that be? Then a would be 0. Does that work? Or have we made an error somewhere? We must have made an error somewhere, right? Because if a is 0, none of the rest works. Right? So let's go back and have a look. Everyone's cool here, yeah? Everyone sees what we did there? We eliminated B. Okay. So now, I made an error somewhere in my algebra, so let's go through it slowly. 2a plus b plus 2a plus 3 equals 4. 4a plus b equals 1. b equals 1 minus 4a. A, B, C. A minus 2 times 1 minus 4a plus 3 times 2a plus 3 equals 7. A minus 2 plus 8a plus 6a plus 9. Where did I go wrong? Because I have the right answer. I did it right earlier. Garumph. What did I do wrong? Okay. Here we're cool. C equals 2a minus 3. Excellent. Oops, 4a. Oh, there we go. Forgot to change the sign there. Because that's minus 3, right? So that's b equals, negative 3 becomes what? When I move it over. That's 7 minus 4a, right? There we go. Now, a minus 2 times 7 minus 4a plus 3 times 2a minus 3 equals 7. A minus 14 plus 8a plus 6a minus 9 equals 7. 15a plus, minus 23 equals 7. 15a equals 30. A equals what? 2. Everybody cool now? All right, now, when a is 2, where can I put that? Anywhere I see an a. So could I put it right there? And what would that give me? C. C equals 2 times 2 minus 3. What is 2 times 2? Minus 3? 1. C equals 1. Now, what's the only thing I'm missing? B. B equals 7 minus 4. What was A? 2. 7 minus 2. 7 minus 8. Negative 1. So, A equals 2. B equals negative 1. And C equals 1. And Madeline, you were very close. I believe you had negative 2, positive 2, and 1. And then, of course, we check, right? 2, what's negative 2 times negative 1 is positive 2, right? 2 plus 2 is 4. 3 times 1 is 3. 4 plus 3 is 7, so I'm good there. 2 times 2 is 4. Minus 1 is 3. Plus 1 is 4. Negative 6 minus 2 is negative 8. Minus 2 again is negative 10, and I'm right. Now, was it difficult? You saw me, I made a mistake, right? Because there's so much algebra. But was it difficult algebra? No. But I made my mistake right here. I did 4 minus 3. I forgot to, because I'm not actually writing it out. I'm working in my head. If I had done that, I probably don't forget that that becomes plus 3. Right? But when I ended up doing it with plus 1, I ended up with a equals 0, and then I go back and I check it, I knew that it couldn't be right. Everybody understand? Now, that 3 variable system, that comes back to haunt you a lot in future math. What if I had 4 variables? How many equations would I need? 4. What if I had 5 variables? 5. And all you do is exactly the same. You find what they all are in terms of something else. So I found C and B, but I left A alone. So once I had C and B, then this C and this B both become A's. Or any other order, right? Did I have to do that order? Could I have started with B here and then substituted B back in? But please notice, I'm using both substitution and elimination tactics, right? I'm bringing everything I know about systems to the party. It would be like doing trig and saying, I don't ever use sine. That would be dumb, right? You would bring sine to a trig party. Yeah? Or if you were fixing a car, you're like, I never use screwdrivers with yellow handles. That would be dumb, right? You bring all your tools to the party. Everybody cool? All right. Let's move on to properties of systems, which is page 183. If I were to graph this bad boy, what would be your first step? You would divide everything by 4? That's cool. So you're isolating y is what you're saying, right? So if he divided everything by 4, Syaj ends up with 3/4 x plus y minus 6 equals 0. And then, of course, he isolates y equals negative 3/4 x plus 6. And he would go up to 1, 2, 3, 4, 5, 6, and go down 1, 2, 3, and write 1, 2, 3, 4, and draw the line. Yeah? Did I only go up 5? I left you guys up. You guys don't have? Oh, really? That's a pain in the ass. You can see I have it. You know, back in the day, when teachers in Abbotsford wanted to print books like this, we sent them to a woman who worked in the basement of the school board. Right over there. She wasn't like a troll or nothing. They let her out of the basement, right? It wasn't like a slave situation. But she did the work, and we got back the books, and they were almost always perfect. But then they decided that it cost too much money to pay that lady to do that job. And they decided it would be cheaper to send all of our photocopying, if we want to make books like this, in a car all the way from Vancouver. So I have to take this document, I email it, but I can't because it's like 300 megs. So I have to email a link to a person in Vancouver. Then that person goes to my Dropbox, gets the file, prints the thing, puts it on a truck, and drives it all the way out here. And we pay the Vancouver School Board to do that. And apparently that was deemed to be a better solution than having somebody from Abbotsford work in Abbotsford. Well, I know that. I'm well aware of that. But also, from a much more selfish point of view, because let's face it, every human being is selfish because we drive our car to 7-Eleven instead of, walking. My books are always printed badly now. I don't know why. Anyways, you guys should have a grid there, but you don't. So, sketch one in. Pain. What would be your first step on the red one? My guess is you would divide by 3. If you follow Sayaj's thinking. And that would get you negative 2x minus y equals negative 33, which would of course get you negative 11, which would of course get you y equals 2x plus 11. Negative 2x plus 11. That would move over there to be positive. That one. Yes. So you would go up to 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 11. It's not on the graph, but I'd go there. And then I'd go down to right 1, down to right 1, down to right 1. And there would be my solution. Yeah? And that solution is, of course, 4, 3. Everyone agrees? Easy peasy lemon squeezy. Yeah? Okay. We're not going to do any conclusions yet because you don't do conclusions until you finish an experiment, right? And you haven't finished an experiment until you've collected all your data, right? So let's collect some more data, shall we? And again, I apologize that you guys don't have the grid. So this first one, probably you're going to divide by 2. You're going to get x plus 2y equals 6, which of course gets you 2y equals negative x plus 6, which of course gets you y equals negative 1/2 x plus 3. And then you would graph it. Down 1, right 2, down 1, right 2, down 1, right 2. And there's your line. Oh, that's a bad line. Yeah? Yeah. Then what would you do here? Again, you'd probably divide by 2. 1/2 x plus 1/2 x plus y plus 12 equals plus 6 equals 0. And you would get y equals negative 1/2 x minus 6, right? And you go down 1, 2, 3, 4, 5, 6. Down 1, 2, 2. And you draw that line. Yeah? Yeah. And then you would turn the page over and you would see, oh crap, more data. So we'd go to here. We'd go to here. And we'd go, all right, x plus, 3y equals negative 2x plus 5. Y equals negative 2/3 x plus 5/3. Then in red, we would do the same thing. 6y equals negative 4x plus 10. You would divide everything by 6. Y would equal negative 2/3 x plus 10/6, which is, of course, really 5/3. And you would see something there. Now, if you were to graph them, of course, we would have to change the scale here, yes? 1, 2, 3, there is 1 for 5/3, down 2, right 3, down 2, right 3. There's the blue line, but the red line would be right on top of it. Now, we have all our data. Let's go back and make some conclusions. What happened in the first one? The lines crossed, which meant what? What do we know if two graphed lines cross? What does that system have? A solution, and it's right there, right? So, the lines crossed. So we got a single solution. Could these lines ever cross again? No, of course not, because they're straight lines, right? All right, let's go to the next one. Will those lines ever cross? No, why not? Right. Parallel lines can't cross. We know they're parallel. Why? Why do we know they're parallel? Right, because the slopes are equal. Since they can't cross, how many solutions? Right, no solution because no intersection. Yeah? Yeah. Let's look at the third line. Those lines are right on top of each other. How many times are they touching? Every single time, right? So, because the lines are the same, they have infinite solutions. Because every blue xy is a red xy. Everybody understand? So when you're looking at systems, you can tell from before you do any work even, or very much work, you can tell if it's worth going on, right? Because if they're going to be parallel, there's no solution. You don't need to do any algebra with the systems. If they're the same line, there's every solution. So you don't need to check both. You only need to check one. And if they're different slopes, then you know there's going to be a solution. You actually have to finish the work. So let's look at this first one. No solving. So no substitution, no elimination, no graphing. How many solutions will that have? What's the hint? So it's been the same hint for the last 3 units. What's the thing that we found in almost every single question? No, we have found x and y in every single question. What have we used in almost every single question? Slope. So check the slope. What's the slope? Do I care about these numbers at all if I'm looking at slope? No, I only care about the y and the x, right? So how would y get isolated there? I divide by 2. So I have one slope of 1/2. Whether it's positive or negative, doesn't matter, right? How would I isolate y there? It's already isolated, yeah? So I don't have to divide anything. So this guy's slope is what? It's going to be 1. Doesn't matter if it's positive or negative. Is 1/2 and 1 different? So they're different slopes, aren't they? So how many solutions? Please notice, I'm not asking for the solution. I'm asking how many solutions there may be. 1. The line can only cross once because it has different slopes. They're not curvy. Let's look at this one. Again, just check the slopes. How do I isolate that? What would I have to do? I'd have to divide by 5, right? And then that would have to move, yeah? So this guy's slope is negative 3/5. What would I do here? I divide by 10. Divide by 10. Y is isolated, so this is okay. So that guy's slope is negative 6/10. Are they the same? Yeah, the slopes are the same, aren't they? Are the y-intercepts the same? Remember, this was divided by 5, this was divided by 10. Is 9/5 the same as 18/10? Yeah. So the slopes are the same and the y-intercepts are the same. So are these the exact same line? If they have the same slope and the same y-intercept, are they the same line? So how many solutions? Infinite. Now, obviously, this is going to be the one with no solutions, right? Obviously, because it's the end of the year, and I'm tired of teaching math, so it's the last unit, one of the last questions, so I'm making it easy. But we're going to go through it anyway, right? Because it looks tricky. Because some of you are saying, oh, Mr. Myers, I'm not going to do all that divide-y crap. 3 times 2 gets me 6. 5 times 2 gets me 10. 9 times 2 gets me 18. Obviously, those are the same line, right? So then, if you do that shortcut, you come over here, you see times 2, times 3, times 3. You're like, oh, those are going to be different slopes because it's times 2, times 3, times 3. And you think that this one is going to cross. But it's not, is it? Because you got to actually do the work. Why is this one more difficult? Because I use P and Q instead of X. But that's not going to fool any of you, is it? As long as I isolate one of them, the other one is the slope, yeah? So it doesn't matter which way you do it. If I were to use 5, I'd be dividing 5 by 2, wouldn't I? Then I'd divide 2 by 2. And then I could move that 5, right? So P would equal, and then that would have been divided by 2. P would equal 5 halves Q plus 15, right? And then down here, I would divide by, since I isolated P, I could divide by 4. And I would get P equals 10 over 4 Q plus 15 over 4. 10 over 4 and 5 over 2 are the same thing, right? Same slope, different y-intercept, one or no solutions. Would it matter if I went the other way? If I isolated Q? Divide by 5, divide by 5. Now I have 2/5 P minus 6 equals Q. Then here I would divide by 10. And I would have 4/10 P minus 1.5 equals Q. And I would see same slope, different y-intercept, still no solutions. Everybody good? Easy peasy lemon squeezy. You're doing page 185. You are doing that until 12:05. Practice systems. Keep practicing them. You see how easy it is to make a simple algebra mistake that blows the whole thing out of the water, right? Okay. Does anybody want to try for a 5 gummy bear prize if I do another 3 variable system? Yeah? All right, I'll write another 3 variable system up there, and you can try to get a 5 gummy bear prize. Deal? Okay. What letters do you want me to use? ABC again? ABC is harder? Okay. Yeah, go. Yeah. Yeah? Yeah. I can't take your money. You're a student. Okay. I like solving systems. I'm kind of nerdy. Hey, I'm allowed. You don't get to do it. Huh? I just said I like solving systems. I'm kind of nerdy. And he went, yeah. That's not allowed, right? It's just like I'm allowed to make fun of stupid old white people because I'm a stupid old white person, right? Just like Russell Peters is allowed to make fun of his heritage, but if anybody else does, it's not allowed. I'm nerdy, so I can make fun of myself being nerdy. Aight? It's hurtful, Jaginder. Hurtful.